This is Ms. Getz again. This is Algebra 2B, Unit 1, Lesson 5. It's going to be Worksheet 8-6 in your packet. We're going to talk about natural logs. Before we talked about logarithms, we were talking about a base of 10. I mean, we were talking about other bases too, but mainly base 10. And now, when we're working with E, then the inverse of working with E, which is that number on your calculator, like if I go into my calculator and I go second E, if I bring it up to the first power, is 2.718. That's what it represents. So when we're working with E, we can turn this exponential function with E into natural log y equals x. Same thing. Natural logs have all the same properties of logs. It's exactly the same, except for it's a base E. So if I were to give you an example of that, I could say 3 natural log of 6 minus natural log of 8. If I were to turn this into a single log, first of all, I know that this can be up here as an exponent. It's the same thing, natural log of 6 cubed. I know when there's subtraction, that means as a single log, it's division. So if I take this in my calculator, I have natural log of 27. That's it. It has the same properties. So if I were to solve with a natural log, I know I cannot solve this. It's just like if I had a log there. I have to first turn it into an exponential function. Okay, so I'm going to write down what I wrote up here. Y equals e to the x can be written as natural log of y equals x. So natural log of y equals x. Then what I'm going to do is, this is actually y and this is x. So I'm going to write this first equals e to the 4th power. Why is it e? Because e is our base. That's why we use natural logs, because e is our base. Now, this can be in the calculator, e to the 4th. So I just go in the calculator, I go second natural log, and that's e to the 4th, gives me 54.6. Now, how do I get rid of a square? Well, I square root it. It's plus or minus, so I have 3x plus 5 equals plus or minus 7.39. Now, if I were to work this out, I'd subtract 5 from both positive 7.39 and negative 7.39. Then I would divide by 3. You know these algebra steps. So x equals 0.797 or negative 4.130. You have exactly the same rules with natural logs as you do with regular logs, except for we're dealing in base E. Let's do another example. Let's solve 7 base E 2x plus 2.5 equals 20. Now, when I have x as an exponent, I need to use logs to get rid of it. But since I have this e here, I know I'm going to work with natural logs. But first, I can't have all these things hanging around with my exponent. I have to first get rid of these things using regular algebra rules. Now, since e is here and there's an x in the exponent, I get to take the natural log of both sides. Now, when I do that, I know the natural log of e cancels out. But really what happens is I have this y equals, remember the thing that we've been using, e to the x, and I can write that as natural log of y equals x. Remember this that we're using? So I have natural log of y equals x. So what I'm going to do is I'm just going to rewrite it as 2x. These cancel each other out. Equals natural log of 2.5. Now, how do I get rid of this? I can put natural log of 2.5 in my calculator. Divided by 2, I get 0.458. Now, if you noticed, when we did compounded continuously, the finding compounded continuously interest, we had A equals P e to the RT. This E is what we've been dealing with these natural logs. So sometimes when we're dealing with this formula, we may need to use natural logs. I'm going to give you an example of that time. I'm going to go to 472 in your book and give you an example of this. So, let me zoom in. Okay, it says, an investment of $100 is now valued at $149.18. $149.18. The interest rate is 8% compounded continuously. How long has the money been invested? So, what they're telling us is in the problem, they said, look, I initially invested $100 at 8%. And when all that was said and done, I ended up with $149.18. How long did that take? I don't know what that t is. But what I do know is that now I have a variable in the exponent's form. So I first can get rid of the 100. Remember, E is not a variable. E is a number, 2.7 whatever, on your calculator. So you're not solving for E. All I did was get rid of this 100. My goal is to get t by itself. But since it's in exponential form, I have to take the natural log of both sides because we're dealing with E. Remember that when you take the natural log of E, you're just left with the exponent. How do I get t by itself? Divide by this. Notice I haven't done anything with the natural log yet. I can just take this whole thing in my calculator and get t equals about 5. It took about 5 years for when I invested $100 to get $149.18. This is lesson 5. You'll be doing worksheet 8-6 out of your packet. When you get into class, I'll tell you what that is.